can degrade it into alkyl phenol in the environment. What the effect if they degrade it alkyl phenol? This one. What the effect? The effect they are very toxic to aquatic life.
Makasih banyak ya, Nu.
Yeah. So
Nurul,
this is
makasih
the
banyak.
many carbon in
Minum, Pak.
here. So this is just one, right? And then this is until 1 until 40. Yeah. But if they degrade it, they will make very toxic. Some IPS are suspected or damaging a human fertility and unborn children. Yeah. You see how this is really damage, yeah, for the human fertility, yeah. Human fertility. What the fertility? Yeah, sperm. And then the
Stretching.
next, this is
Stretching ya.
the derivatization of uh, alkyl phenol methylsilate. Yeah,
Atau
this is the
disebut
derivatization. There are nonylphenol,
TOOGLING.
oxetylphenol, nonylphenol, and etc. This is just derivatization. Yeah, derivatization.
STRATCH.
And then the second one is azoamine or aryl amine salt. This
TOOG.
second substance. This is azotase and pigment where we use colorant. Yeah, this is for colorant. Incorporate one or several azo group bond in with aromatic group. This is for example, this is the amine group, right? Why certain azotase and aryl amine salt as reflected? Yeah, because mostly they breaking. Yeah, if they break, yeah, the uh, bridging, this one will break. The certain azotase can break down through reductive cleavage, resulting restricted amine or aniline fragment, which may result in the development of particular cancer long-term exposure above certain limit. So it's also trigger for the cancer. Yeah, that's why the RSL and also
ABT.
MRSL is
ABATE.
really have to obey. Right?
Itu nomor pertama.
This is just a derivation as well. This is the how much number we need to consider. This is limit component material in the finished product. It should be below 20 ppm. How much 20 ppm? How much 1 ppm? 1 ppm equal to
Sesuai kelompoknya deh ya.
1 gram
Sesuai
milligram,
kelompoknya ada yang penyama
1 milligram per
mimosa, ada yang penyama krom.
how much? Okay, yeah. Because the unit for this one mainly with the ppm. Yeah, mainly with ppm. You can just
Iya
take a
deh.
look how much milligram. And then the third one is bisphenol. You can just read it. Okay. This is why it's also restricted. This is because suspected to have endocrine disruption properties similar to BPA. Yeah, endocrine disruptor. Did you know endocrine disruptor? Apa? Breaking the endocrine hormone. Okay, yeah. This is just also the derivation bisphenol A until bisphenol EF. Yeah. And then the fourth one is chlorinated paraffin or short chain as medium chain chlorinated paraffin. This is look like similar, yeah, with the chlorine in here in every carbon. See? in also methyl group in here. Classified as persistent organic pollutant and very bioaccumulation substance may cause skin dryness or cracking on eye irritation. Yeah. So who student here doing job in the not job actually it's just internship in the leather industry? Not yet, yeah. Okay, so we have to consider ASWA. So we have to consider about this restricted substance, yeah. When you meet it, yeah, when you meet them, this is just. And then the fifth chlorophenol. This is highly toxic by inhalants and also skin contact. Okay, 10 minutes left. This is like a pesticide preservation for
Wadah,
textile and
udah
leather
kecil.
material. Usually,
Kalau lagi,
when you finish the leather, and then we need to store it, right? We
tak,
need to keep it
itu
in
kayak
the certain temperature or certain rooms. We need to put or we need to spread with the chlorophenol to get preservative for textile and leather material. And how much for this? The limitation is zero point 0.5 ppm, really small. Yeah. Reporting limit above which this result should be reported. For example, if you have product from the leather product and then the reporting content of the chlorophenol above 0. Above 0.5 ppm, we should you should report it. Yeah, we cannot allow to ignore it or hide it. Yeah, we cannot allow to ignore it or hide it. We have to obey with this one. Yeah, and then the six, yeah, dimethyl fumarate. This is also painful dermatitis and acute respiratory difficulties. Yeah. So there are six. Now it's already six. I think it's a lot. I think I will skip. Maybe you can read by yourself. Formaldehyde, heavy metal, and then what else? Okay, and then I think this one, yeah. This is the substance very high concern. Yeah, this is for the high very concern. Serious effect on the human health or environment. Individual substance or articles contained within a complex product, carcinogenic, mutagenic, or toxic to reproduction as well as substance with
try itu
persistent
90
and bioaccumulation characteristic, endocrine disrupting chemical as well. Yeah. Individual substance and article within product may not contain this one. Yeah. Substance very high concern over the allowed after the low 0.1%. How much for the ppm then? 1 ppm how much? 1 ppm is equal to 1 milligram per yeah, is same. Yeah, 1 milligram per liter. But 0.1 it means
oh iya deh
0%.
ini
It means equal to 0 how much?
oke
0.0 how much ppm? 0.5 ppm is 0.5 gram per milli. Yeah, this is equal to 0 ppm. Eh?
saya tahu
Okay, and then the last, when we do all of them with the MRSL and RSL, and then you
ini ada
compile with that, with all of them, how you make convincing the buyer, yeah, how you discussing that your product is already obey with the two of both of them, MRSL and also RSL. So first we have to find out all the substance, yeah, we have to discover or find out whether the substance is present in the product or not. Yeah. And then the second one, identify the low requirement of the substance of all. So we have to take a look the data list from two MRSL and also RSL, whether they are in the below limit or not, or few of them is the above of the limit. If the above of the limit, you have to do tracking, yeah, tracking. What happened with this one, with the during the process, and then the
Dari
last,
marah
sorry,
lagi
and then
sama
making
orang
the
Bayu nggak mau gagal di
NRS
sini.
of this is
Karena kapan
it
kalau
means
gagal di
way
sini
X.
Bayu yang
This is
salah.
we compare with the
Nah,
standard, with the
Bayu nyelesain
limitation, yeah.
semuanya. Bayu
And then
nyelesain semuanya.
ensuring the supply chains to compile the RSL
Nggak pernah kali
with
ini
the
Bayu punya pilihan
standard
terakhir.
as well.
Bayu saya dari waktu
Okay,
pemeriksaan.
I think just finish in here. I hope will fulfill your expectation. I think thank you very much for the attention and also the participation. I give back to the Mbak Yevana. Thank you.
Okay, thank you so much,
Oh,
Dr. Zainal, for the comprehensive presentation. We greatly appreciate your time and contribution to the session. So next, we will continue to the Q&A and discussion session. Participant who would like to ask question may kindly raise your hand and or type your question in the chat box. So, okay, so we have Aura Zahwa Shaira. What are the biggest challenges in replacing SPHC chemical with safer alternatives in leather manufacturing? Do safer substitutes always provide the same leather quality? So please, Dr. Zainal.
Okay, thank you, Mbak Aura, for the question. So, what are the biggest challenge in replacing substance very high concerns chemical with safer alternative in leather manufacturing? Do any safer substitution always provide the same leather quality? So as far as I understand, for the substance a very high concern, I think we will they will still present in there. Yeah, but the limitation we have to consider.
amin.
Yeah, we have to consider. I think if you want to take a look how much the amount which should be in the leather product, we have to take a look in
Nggak
detail. We have to check
usah
the link in here, Mbak Aura. But if you want to change the substance very high concern with
dari
the, for example, with the bio-based,
dari kayu serat
biological material,
serat
is also
kayu.
possible, but maybe still I think will influence in the
Kelihatan
leather
deh.
product, in the final leather product. Yeah, we don't know yet how much the significant between the natural and also with the substance very high concern. We don't know yet. I don't know yet. Yeah.
Okay, okay, thank you, Dr. Zainal, for the answer. So maybe anyone want to ask a question?
I think it's clear.
Okay.
Oke, lanjut Mas. Slide pertama itu sampul. Sampul itu
Thank you. First of all, allow me to introduce myself. My name is Adin Kita Nareswari. Adin, I'm student of animal science chemistry, and my question is based on your experience, Dr. Zainal. Uh, could you share some examples of Indonesian leather brands or company that have successfully or maybe
Okay.
already implement
Yeah, yeah.
the or obtain the certification
Okay.
that you mentioned it? Thank you.
Okay. So for the on-site session, so for the next coming weeks, yeah, for the on-site session, start from 1 June, we will visit one of the famous leather industry in Indonesia, and then they already have the LWG certification. Yeah, we hope you can learn all of them there. Yeah, all of them, whatever present in there, whatever in the processing and also the product. I hope during the visitation you can feel free to discuss with their company. Yeah, you feel free to discuss with company, and then also that company actually they also have the gloves, what we call it, yeah, glove leather, yeah, industry glove leather, but separate. But we are not visit that, but we only just visit on the leather industry. Yeah, that's it. Yang terus.
Okay, so thank you for the answer. Or maybe we have another question from the chat box,
Oke,
but in Indonesia, maybe I can. Yep. Bagaimana?
nggak apa-apa.
Bagaimana upaya-upaya restricted analysis pada produk hewani dan nabati dari produk penyamaran yang dapat meningkatkan perubahan keawetan kulit hewani ini meno- lebih menonjol sama ada penyimpanan dan implementasinya steril.
Gimana semacamnya? Pak siapa? Gimana Pak? Lebih singkatnya gimana Pak Bayu?
Ya, baik, terima kasih
Can you repeat?
atas kesempatannya. Izin memperkenalkan diri Pak, saya Ahmad Bayu Aryawan, alumni Fakultas Peternakan di Univalu Ulio Kendari, Sulawesi Tenggara, pemerintah teknologi hasil ternak. Ini engineer Bayu memiliki keinginan sekali untuk mengembangkan penyamakan minyak atau oil itu menggunakan lebih ke lemak hewani Pak, yang memiliki kandungan kental dan jernih serta ada kandungan trigliseridanya Pak, engineer yang membantu bagaimana penampakan kulit itu lebih crush begitu engineer Emza. Yang mohon maaf kalau mungkin ada pertanyaan kurang memahami kepada engineer. Yang jadi pertanyaan adalah bagaimana upaya-upaya restricted analysis pada produk hewani dan nabati dari penyamakan ini bisa meningkatkan perubahan keawetan lebih menonjol pada kulit hewani, sama ada penyimpanan dan implementasinya itu memiliki lebih fokus pada penyimpanan dan implementasinya itu dia terbebas dari kontaminasi, maksudnya engineer Emza. Mohon izin, demikian. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Oke, baik, terima kasih. Saya jawab bahasa Indonesia ya Pak. Jadi yang penjelasan yang saya sampaikan pada siang hari ini itu mengenai batasan-batasan substance atau senyawa yang diperbolehkan dalam penggunaan proses penyamakan. Ya. Jadi ada beberapa substance yang perlu diperhatikan dan itu menjadi aturan dari seluruh dunia gitu ya. Ya bukan seluruh dunia, tapi hampir banyak aturan di leather industry they follow MRSL and also RSL gitu. Seperti itu Pak Bayu.
Okay, thank you so much for the answer, Dr. Zainal. So maybe we have another question from offline participant.
Udah belasan. Udah. Okay. Any question?
So maybe another question for Dr. Zainal.
How to get ini? Enggak ya? Okay.
Kalau bisa ini kan cewek sama cewek
So the restricted substance means we only just keep the limitation. We cannot eliminate, just minimize. Yeah, keep in mind we only just minimize or do the limitation what the present in the legal contains. Because if we element is little bit difficult to to find another substance that can replace. Even in the bio-based material is also present. But nowadays they are still
Semuanya.
growing to look for the another bio-based substance. Yeah. Because there are the, I think it's many from here. Any more questions or just little bit sleepy? I think it's better to take. Okay, thank you, Mbak Jevana.
Okay, thank you so much for Dr. Zainal for the inspiring for the presentation and also interesting discussion with more than 20 years of experience in the leather and footwear industries. His expertise in sustainable production, environmental management,
Domainnya juga bisa
chemical and
untuk ini. Kalau tidak salah ada beberapa penelitian di
precision.
Kendari itu
He currently works
dijadikan
as a
kayak
senior process
apa
engineer and sustainability manager
pupuk
at
kah apa
Apex
dari mana
Footwear
gitu.
Limited, Bangladesh, and is actively involved with the international organizations such as ZDHC, UNIDO, GIZ, and the Leather Working Group, LWG.
Oh,
And he is also certified as an auditor and trainer in environmental and sustainability management system. So today we are honored to hear his insight and experiences on the topic process optimization for cost reduction and quality improvement. So without further ado, Mr. Firoz, the time is yours. Oh, please let me
Mbak,
check, Mr. Firoz, are you with us?
zero waste di sini. Percontohan begitu. Andai-andai saja.
Okay.
Hello,
Mr. Firoz,
good afternoon.
Lanjut.
good afternoon. So we will have a presentation, right?
Yeah, already shared with you. If you don't have, then I can share.
Maybe you can share your own, or maybe we can help. Which one you prefer?
Ada.
Untuk ini mau satu malam mau karena itu RPH-nya memotong sih jam 6. Iya dari jam 10 kalau kayak jam 6 itu memiliki.
So the time is
Jadi
yours,
kalau
Mr.
badan
Firoz.
lambat selesainya nggak ada sama sedikit tuh.
Thank you. Once again, Assalamualaikum to all participants. As you know, I'm Mr. Firoz, just doing work in a Bangladesh leading shoe manufacturing company, Apex Footwear Limited, and also I'm the faculty of Bangladesh world-renowned university, East Coast University, and trainer of ILET, Institute of Leather Engineering and Technology, Dhaka University. And myself, a leather technologist, I passed the basic leather technology. So,
Sebelumnya
welcome all animal husbandry students.
Nah,
Today,
saya mau memperkenalkan ya, Bayu mau perkenalkan.
the process of
Jadi kalau yang Bayu lihat di maps itu sebelum gerbangnya gerbang yang ke goa di belakang. Iya. Kalau dari Bayu diberitahu sama Kak Ilham kemarin.
First of all,
lebih mudahnya. Nah,
start to know
itu di belok kanan itu
process
namanya
optimization is a
SPPG.
process where
Dewati kok
we
SPPG.
can save the waste,
Belok
save the
kanan yang ini yang
energy, save the
sampingnya
water,
yang toko bangunan
save
itu
the
yang gerbang
all
gerbang
input,
goa ini
and
deh. Baru
manufacturing
setelah
in
itu
such a way that will give you the best
apa nama
output.
belok ke
So
kiri,
here is
belok ke
the
kiri,
key
belok ke
points
kiri. Di situ
to
nanti
reduce the cost,
di
because
situ kan tempat pemotongan.
water
Tempat
give
pemotongan itu
we
dekat
in
kuburan. Kalau Bayu lihat
input.
di
Suppose
Google Maps deh.
since we are discussing about the leather manufacturing, so in leather manufacturing we are using raw material like rawhide, or if the manufacturer starts from the wet blue or manufacturer starts from the grass leather, then these are the raw materials. After that we added some chemicals, then process, then it comes to the final output. So raw material, we have to optimize the raw materials, we have to optimize the process, then
Waalaikumsalam warahmatullahi
we are going to sell
wabarakatuh.
the product, then
Sampai ketemu
it
besok
will become
semuanya.
profitable. So through process optimization,
Terima kasih banyak ya
we can be
perjuangannya.
benefited by the cost reduction, as already I mentioned. Improved
Bersadu.
efficiency means that
Bersadu.
so many
Tidak di
ways.
sini dulu.
It
Di
means
apa aja?
time, it improves also the
Iya.
quality, and it
Mau
also
tutup.
helps to improves the maintain the consistency of leather. And competitive advantage, if one manufacturer of one tannery owners can practices the optimization, then he or she might be benefited through the price, because optimization helps him or her to reduce the cost. About 6 steps we can start this optimization. One is identify the goals. Our goals is to reduce the cost, analyze the current process. So if we have a practicing one traditional process, like we'll use the 1,000 parts of water and 100 kilos of chemicals for the 1,000 square feet of leathers, then this is the benchmark, and from here we have to analyze how we can optimize the process. Then we have to design the process that we might have to reduce the water, we might have to reduce the time, then the it may be comes the final output. If this output is comes, then we can take it as test basis, then we'll go for the next bulk production or the big production, then we can continue the overall process. There are so many frameworks around the globe to optimize the process. One is DMAIC, that means define, measure, analyze, improve, and control. You can easily align with the previous 6 steps, that we have to set the goals, identify, trial, then bulk production, then continue. So this is very similar of the DMAIC method. Another is Kaizen. It's the Japan traditional method of process optimization. It can help to reduce the waste generation. And another is PDSA or PDCA, plan, do, check, act, or plan, do, study, act. This is the standard procedure. Then another system is Six Sigma. This is also the just a standard methodology to optimize the process. This also helps to reduce the error or reduce the waste, and its value the final product, and helps to reduce the cost. Next is the SIPOC. It means supplier input, process output, and the customer's key process. This is a little bit different.
Sorry,
You have
Mr.
to
Firas.
start from the suppliers.
I'm sorry,
Yeah.
the material is not yet fully showed, so maybe we can see if the slide is changed.
You can see.
It is still in the first page.
Now, okay.
It's freezing, like, because it's not fully showed. Maybe you can click the
I am seeing.
show.
One slide is not showing. Quickly fast forwarding.
Or maybe you can send the material to us so we can help
You
you
can
to.
see now? You can see now?
I can see, but only the first page.
Oh, sorry. Then it's already sent through mail. You can take and you can share. Then I can explain from here.
So please send. Oh, maybe.
Can you share the mail ID? Just I will share at a glance with you. See, or I am forwarding the same mail ID.
Did you send it in chat box or?
Yeah, I'm sending.
Sama aja saya minat nih, minat saya kita itu. Besok anak dia tuh. Jam? Jam apa? Jadi datang ke sana. Jadi datang sih. Kalau datang lah, pasti cuma pulang. Jadi kita harus kembali. Iya. Iya, bro, yang mau tulis sepatu. Kita tanya siapa saya mau beli. Dan kita kasih lagi. Saya sebagai tapi berapa sih? Apa?
Yes, I sent.
Kasih dia. Bisa tidak? Sama kita mana? Ada apa? Dua. Sama kita dia mana tadi? Pas lah kita kuliah. Kalau dia mana? Apa nanti mana bisa masuk cerita tu? Rasa apa itu? Maknanya kita sudah. Beda sapi. Tahu?
It's already sent.
Oh, mungkin makan itu.
Can you hear me?
Okay. So we will try to present your
Yeah.
material. Please wait.
Sorry for this inconvenience.
It's okay. It's fine. Okay. Mr. Firoz?
Yeah.
You can start.
Again, restart. You can go to the slide number 4.
Your presentation.
Next slide. Next slide, please. Yeah, it's okay. So, dear participant, I apologize for this unavoidable errors. I already shared, but maybe some network issues. It's not displayed from my PC. And now we can start. Just if you can go to the previous slide, please. So as I said that through the process optimization, we can follow the 6 steps: identify the goals, analyze current process, design the process optimization, test. That means we can trial basis, we can run this process. If it is okay, then it can be implemented, and then we can continue this process. And now the question is how we can implement this process. Next slide, please. So there are many standard framework around the globe. I will presenting here only the few method. One is DMAIC, that means define, measure, analyze, improve, and control. Another is Kaizen. It's the Japanese traditional method just to implement the waste reduction and improve the cost efficiency. Another one is PDSA or PDCA, plan, do, check, act, or plan, do, study, act. Is the same. Just we have to plan, then we have to implement, then we have to check that either it is cost efficient or not. Then act, we can keep it continue for our sustainable manufacturing. Then Six Sigma is the well-reputed and well-renowned method. It reduces the cost through the waste optimization. That means reduces the waste. And another one is SIPOC. That means suppliers, inputs, process, output, and the customers of key processes. This is SIPOC. No, I will explain this SIPOC. Please stay this previous. SIPOC, these process start from the suppliers. That means from the beginning, I told you that we have to input in an industry for the manufacturing. Suppose if it's the leather manufacturing in a tannery, then we have to purchase the raw materials like raw hides and chemicals from the supplier. So we have to start from the suppliers. If we can choose the right raw materials, right product in a minimum cost or standard market value, then it automatically helps to reduce the cost. And also, as the previous respected lecturer told, the RSL, if the chemicals are compliant with the RSL, then it will helps to comply with the also the reduces the manufacturing cost. Then raw material is input in our inventory, then we can start the process, then finally outputs, and the customers, if customer feedback is good, that okay, this material is good and comply with the all standards, meet their satisfaction, then they can continue. And end of the day, it will help to reduce the cost. Next slide, please. So another process, this is the lean manufacturing principles and techniques. The lean manufacturing is a value stream, identify and map the steps. That means we have to identify from where we will start and which steps we have to follow to reduce the cost and optimize the production, then continuous improvement. Then every operation and everything, every material have to be in-house just in time. Every operation have to be functional just in time. If everything is just in time, then it will reduce the time. Then we can say the process optimized and the final output is good. Then we can standardize this, the workflow. For the leather manufacturing, it's a responsible and sustainable sourcing, ethical sourcing, animal welfare, and you are very much aware since all of you are the animal husbandry students, and I'm glad to share my experience in front of you. And I think I will also learn from you through your question. So then reducing the tanning impact and just helps to improve the ESG scope. Next slide, please. From the previous slide, I told that we have to make sure that all material is available in-house on time. So if the material is in-house on time, it makes the total inventory is on time, then it will help to reduce the cost and improve our process efficiency through the cost saving. and finally the increased accuracy. But it has some impact. If the material are not on time, then it will take more time, and process needs the more time. Then we cannot say that we optimize the process, because we are running this process in an extended period of time. And vendor also, if the supplier is not, as you are aware, one student asked about the LWG, that if the vendor is not compliant, that he or she or the vendor might not be supplied the appropriate raw material. Suppose if one leather manufacturer is started from the tan leather, that means wet blue leather, then he might be purchased from the wet blue from the another supplier. If the wet blue supplier is the LWC certified or the compliant, he might be a practitioner of the process efficiency, and the supplier can sell or can provide the wet blue in a efficient way and good leather. Then we can use, if we can purchase the 1,000 square feet of wet blue from a certified or compliant or any renowned vendor, then we can say that this leather quality also be good. Then we can use this 1,000 square feet of wet blue to manufacture the crust and the finished, and the final output will be very much similar, and it close to be near 1,000 square feet. So by this way, input is raw material input is 1,000 square feet, manufacturing process, and final output it may be close to the 1,000 square feet. That means it will help to minimize the cost, because if the raw material shrink or raw material reduced or the raw material scrapped, then the final output may have the additional cost. So vendor and the supplier here can play an important role. Next slide, please. Now the main topics, that the leather processing. As you know, I think you are well aware about the leather processing, because so many lecturers or so many presenters already shared it, but I'm repeating it. Raw hides, wet processing, then it comes to the wet blue, then refinishing, that means retinning, then crust ready, then finishing, and the final leather manufactured. Here, the process efficiency starts from raw hides. Like, as you are aware, since you are the maximum students of the animal husbandry, so animal welfare is a big issue to get the raw material from the healthy and the good animal. That means if the animal, suppose a cow is healthy and disease free and is in good in health, then through its slaughter for the meat, after that as a byproduct we can give the hides. If the hide is defectless, that means its flaying is the scientific way, no flake cut on the grain side, and the flesh side there is no spot, there are no tick marks, no pox marks, no vein marks, no pinhole. If it is risk free and the leather is cured on time, then we can get the good quality of raw hides. And if everything is processed in a scientific and organized way, then here also we can optimize, in some cases not optimized, but it helps to keep the leather quality good. Then this good quality leather also we can sell in a appropriate price, because suppose if the one raw hide is 30 square feet, and this 30 square feet is fully usable, it seems to be usable or good, then one leather manufacturer can purchase it at a better price. So it also helps to improve the cost for that raw material supplier. Then we can start from the wet processing, that means tanning process. Here we can pre-soaking, soaking, liming, deliming, batting, pickling, and finally tanning. Here is just water is a valuable resource of our globe. As all of we know that around the globe, 2/3 is water, but out of this 2/3, only 2% water is sweet water. That means is usable water. This 2% water, out of this 2%, very minor quantities easily extractable from the ground. In some cases, this sweet water can extract from the very deep of the soil layer. So water is a very natural resource. Since we are aware about the sustainability and the environmental issues, so we have to optimize from starting of this process, very beginning of the process, from the wet processing of leather manufacturing, like in soaking, pre-soaking, we have to just optimize. If we use the through the automated dosing system, that if we need 1,000 liters of water, then the machine will dose it the 1,000 liters of water. It's okay, but the leather manufacturer might be installed the automated dosing system just to optimize the water consumption, because we require the 1,000 liter, then the dosing have to be 1,000 liters appropriately. So by this way, we can appropriate the we can use the appropriate quantity of water. Then we have to use the ZDAC MRSL, manufacturing restricted substance list compliant chemicals, because there is a main tanning agent is basic chromium sulfate. You know, as per ZDAC, there are some limitation, as you learned in previous session, that the chromium 6 have some standard limit value. So we have to confirm from the supplier that supplier must be supplied this basic chromium sulfate complying with the ZDAC MRSL. Then we can use these chemicals. Then we can be easily safe that our chemical is safe. Then optimize the exact quantity of water we are using. Then tanning process perfect. Yeah. If we are not using the exact quantity of water, then what will happen? If we use the more quantity of water, then the concentration of basic chromium sulfate will be diluted. Then the basic chromium will not penetrate inside the pelt, that means inside the leather. Then the tannage will not be perfect. End of the day or end of this operation, the wet glue is not perfect. Maybe some looses or maybe some unnecessary defects there. And if chemical is not compliant with the ZDAC MRSL, then
jadi beliau ngajar udah lama. Setelah itu di STP berubah jadi STPP. Dari STPP perbankan.
Next slide, previous slide, please. I will take a maximum time with this slide, because the rest of the slide will reflect this slide. I will just proceed with this slide. Then the wet glue will not compliant of the RSL, restricted substance list. That means there might have a possibility to occur in chromium 6 that is hazardous and carcinogenic for the wet glue. So ultimately, if the wet glue consists of chromium 6 in a certain level, that means above 3 ppm, then it will not pass the quality. Then if the process is optimized, but finally if not passes, then ultimately final output will be zero, not added value. So we have to optimize in every stage of in leather manufacturing. Just refinishing or the returning process is same. We have to use all the chemicals of compliant chemicals. Then crust is ready, and finishing also we have to follow the same process. Next slide, please. As I told, here is the just on a graphical presentation that rawhide, chemical, water, and fresh air input in a tannery, and air added on energy and manpower. Then it output the wet glue, crust, and finished leather. And finally, every raw material has some. There are some few outputs. One is main product, that means our expected products. Another is there have the opportunity to generate these that manufacturers generate byproduct or co-product, and some effluent. Effluent maybe it may be liquid, it may be air, it may be solid. In leather manufacturing process, there are 3 types of effluent generated. One is liquid effluent, air pollution, liquid effluent generated from the every wet process, air pollution basically mainly from the finishing and solid waste in beam house, that means wet processing, and some in finishing stage some trimmings and some chemical wastes is happened. But here also be a major concern of the process optimization, because if we are not optimize this waste, ultimately it will pollute the groundwater, pollute the atmosphere, that means air, and also pollute the solid waste. So we have to control, or we have to be sustainable by just treating the liquid effluent, controlling the air emission, and created the solid waste or the recycle or reusing this solid waste. Nowadays there are so many steps for the treatment, effluent treatment through the functional ETP or CTP. We can treat it and say that our product is safe. And solid waste, we can make it some recycle product, or we can reuse in some cases. Next slide, please. Now in the processing details in beam house, as already I covered this area, because sorting, trimming, curing, soaking, liming, all our stages, every stages we have to apply the right chemical, right amount of water, right chemical dosing, and the appropriate timing. We have to check every timing, like we have to maintain a process sheet, and if it is for the 30 minutes run, we have to check, then we have to check the quality. If quality is okay, then we can proceed for the next procedure, returning the same and finishing also the same. Next slide. Here already I told that sustainability consideration in manufacturing waste. You know, in present concept, waste is not waste unless it's wasted. That means if the waste is used like in small trimmings of leather, and if we make it, convert it to the key ring, small key ring, then we cannot say this is waste, because leather like the 1 square feet or half square feet of leather, if we it's wastage from the main leather, and if we convert it to the key ring or some small component, then it will die. Then we cannot say that this is waste. So unless or until the waste is not wasted, that means that has no commercial value or the not importance to the any other previous operation or not using in any other circumstances, then we can call it a waste. But if we can reuse, recycle in any cases, then it is not waste. So it's the key elements of the process optimization in every stage. It comes from the raw materials. That means in leather, you know, from the beginning, it comes from the raw trimmings, and also since we are using the cured leather, that means salted hide or the brain salted hide. So there we can just mechanize desalting. We can remove the salt, and we can use this salt mixing with the virgin salt for the next lot of the raw hides for curing purpose. So there the curing cost will be reduces. So if we started the reduction of waste generation and started the recycling or reuse the waste, then it is a big tool to optimize the process, and a big tool to reduce the cost of production. We can start from the raw materials and from the every stages. Energy is a key tool. You know, in previous slide I already mentioned that raw material imported in the tannery, then energy, that is electricity, that means steam energy, that means fossil fuel energy, that means natural gas energy, whatever you uses, wood, coal, charcoal, whatever you uses, all are the energy resources. Since every resource is not unlimited in the world, Allah give us all the resources limited, but we have to explore how we maximize the use of these energy resources. So resources, we have to minimize the consumption of resources. Just through process optimization, we can maximize the output. Suppose for boiler, you know, for the leather manufacturing, especially for the hot water and the finishing, need a boiler, and to run this boiler, we need the natural gas or LPG or wood or coal or any or even in electricity, any energy resources, we need it. But in boiler we uses hot water, just water, it comes to hot, then it converts it to the steam. Steam reverse is to come to the in machines just to heat the heating chamber and it dry to the leather. So in boiler, if we use the condensate recovery system, then you can see the steam, whatever is uses in our process, the rest steam will be recycled to the boiler again, and it heated the that means inlet water, feed water, it automatically preheated. Suppose in natural water, if its temperature is 28 to 30 degrees centigrade that we extract from the ground, then this steam automatically reverts back to the boiler feed water tanki. It can be preheated the steam 80 degrees. Then we can feed this water to the boiler tank, then it converts it to the more than 100 degrees. That means it converted it to the steam. Then it's again recycling to the process to heated the heating chambers. So by this way, but we are consuming the fuel like the NG, natural gas, or the LPG, or even in diesel, the same quantity, but we prevent the loss of ultimate energy. That means steam energy. Steam energy can recycle and it helps to heat our feed water. So by this way, we can reduce. There are so many activities. By this is I gave you one example. By this way, we can optimize the consumption of energy and get the maximum output of this energy. And it also helps to optimize the process and also reduce the cost. These costs will affect the ultimate final product. Then comes to material. Material means, as repeatedly I told, it may be raw material, it may be chemical, it may be even in energy. It's also in for the energy generating equipment, it is a raw material. So we have to choose the right material, right quality material, and make sure the optimum use of this material. Water already I covered, logistic already I covered, then training, everything. If I don't know, then it's not possible to repeatedly, or it's not possible to implement or the continuously following. So people like you are joining here, I think after passing or already those are passed, you are working, you will be through this lecture. I think if it is helpful to you, you can practice this, how we can optimize the process, reduce the waste generation, optimize the energy consumption, choose the right material, and minimize the water consumption. Everything we learned, and if we implement this in wherever we are working, even in our home, then it may be save the ultimate cost, and final output will be good and in a less price. Next slide, please. This is an example of how we reduce the water consumption. Process redesign, as I told, that where we have to use the 1,000 liters of water, then we can try the 800 liters of water. If it is okay, then end of the day or end of the month, we can say that we are successful with the 800 liters of water. Then we can continue with this. This is a single steps to reduce the water consumption and optimize the process. And metering system already I told you, and in the installation of condensate recovery, I explained before, water loss, leakage, everything. If we can comply, then it may be helpful to optimize the process and reduce the cost. And another is, since I told that water, we have some scarcity of water for the fresh water that is using. So we can optimize or we can reuse the rainwater through the harvesting process, and it will help to conserve the natural resources. Next slide, please.
Bruto.
Optimize the energy. Already I covered the thermal energy, and the latest trend since that the time is very constant, so I will not explain here in details. But latest system is the IoT, and through this IoT Internet of Training, we can online monitoring the everything, and it also helps to reduce the energy consumption and optimize the process. Next slide, please.
Nah, setelah Bayu goreng,
so now we can come to the main process. That means I told a little bit, but here we can go in details, like the high exertion of chrome. From the raw material, when you process the chrome, you know, I mentioned at the basic chromium sulfate. That means the chromium must have some certain level of basicity that is very much helpful, and the certain level of pH that may be very much compatible with the felt or with the height. If we process the chromium sulfate in higher pH, then it will not penetrate inside the leather. That means surface sedimentation is happening. So right chrome we have to use, and nowadays there are so many new process, that means low float chrome tanning. If we use the low float chrome tanning, then exhaustion, that means chrome penetration, will be high. So we have to and the effluent generation is very low. That will help to, suppose previously we are using 8% based on the pelt weight, 8% chrome. That means in 1,000 kgs of pelt, if 8%, then 80 kgs of chromium sulfate we need. But if we use this chrome in concentrated bath, then it may be required 6%. That means 60 kilos. Here we can save the 20 kilos of chromium sulfate. But due to the low float of this tanning bath, chrome can be maximized to penetrate inside the leather. So here we can save the 20 kgs of chrome cost, and through the less float, the penetration will be maximized, and the penetration will be high. So a minimum amount of effluent generated, and you know, in ETP or effluent treatment also incurs so many costs. If the cost is one unit, that means since I'm talking from Bangladesh, you know, in Bangladeshi taka, if it is 1 taka or $1, then we can save the 20 kilos of basic chromium sulfate. This is the cost. And effluent treatment, if it reduces that 20 liters or 100 liters, even 200 liters of effluent, then it also saves some cost. So the process optimization, that means right amount of right quality of, I can give this example, chromium 6 in a low float, it saves the, first of all, it saves the quantity of chrome, that means cost. Second, it maximizes the maximize the chrome penetration, and lastly it minimize the effluent. So these 3 steps we can reduces the cost and maximize the penetration and maximize the quality of leather, and it will help to give the profit. Next slide, please. MRSL already I covered. If we choose the right material, then there is no failure. So right output we will have, and if we tested it past first time, then we can no repeatedly tested. It will also save some money, and we can offer the ultimate customers that our product is safe, and we also offer them the higher price since it is safe. So we confirm. So it will also through this confirming RSL, it also helps to maximize the profit, that means cost. Next slide, please. Challenges. So I have some time constraint limitation. Already remind me only most probably now it's in 8 minutes. So now I am also very close to end of my sessions. So challenges in current leather manufacturing process, I can summarize this: the increasing of labor cost in so many countries due to the global circumstances. Living wage is a matter. So labor cost is increased. So if we don't have anything to do in this labor cost, since we have to follow the legal regulations, so if we can optimize the process and minimize the manufacturing cost, it helps
Baik
to
juga mau
solve
pulang
or
nggak tahu sama
minimize this
siapa.
problem. On inefficient production layout, it's an important thing. If suppose in beam house, tanning drum is the east side of a tannery and fleshing machine is the west side of a tannery, then it takes so many transport costs from here, and it also loses also some so many times. Times means money. So every tannery have to lay out properly that chronologically we have to set up the machine from this machine to this machine, this machine to this machine, starting from point to ending. If layout is like same, then it also helps to optimize the manufacturing process. And operating technology, third problem is the technology. There are so many technology. The leather manufacturer have to adapt this technology to optimize the chemicals and maximize the profitable output. And supply chain, in global situation, there are so many obstacles to supply chain, but we have to ensure the localization of the material. If the material is localized, then it will help to reduce the lead time and onboard or in-house all the materials on time. Then it also helps to reduce the lead time and also increase the profitability. Next slide, please. Any question?
Okay. Thank you so much, Mr. Firoz, for the presentation. So maybe we will have a discussion session, Q&A. Maybe online participant can type your question in the chat box, and also the offline participant can raise your hand.
Pulang. Selamat.
Is it already clear from the presentation? Or maybe there's any question, please? Okay, so we have one question from offline participant.
Please, speaker, read this question, then I'll give the answer.
Yes, okay. Thank you, Mr. Firoz, for your interesting presentation. My name is Aswa. I'm currently in the room right now. I'm just a little curious about your explanation is in closed loop Chrome recovery. I'm just curious if
Ya, Dek.
it was for
Salam.
the maybe like a lot of cycle, like 5 time or 6 time tanning
Itulah
process.
ngata siapa yang ngantar.
Is there
Jadi dia juga bawa
any
ukurnya ini.
different quality of the tanning process than
Ya,
the first
Assalamualaikum.
cycle by using the recovered chrome
Ya,
layer?
Assalamualaikum, Dek.
Is
Fat.
it clear for my questions?
Yeah, I think just you're talking about the recovered
Ntar pulang.
chrome
Kau lewat
layer.
mana, Dek?
Yes, I'm
Kau
sorry.
lewat mana?
Yeah.
Oh,
If we
berarti
use the
kalau
closed
WhatsApp.
loop
Oke, lewat WhatsApp.
of the successful
Kata
chrome recovery
Timo.
system,
Ya,
chrome
Assalamualaikum.
recovery is not very tough to recover chrome. Just we have to sediment the chrome anyway, since there might have some to sediment this chrome, we have to increase the pH. And after that, it's sedimented, collected the sedimented chrome, then we have to acidify this chrome just to
Oh, yes.
reduce the pH of this chrome to
Hati-hati,
compatible with
Dek.
the
Assalamualaikum.
leather.
Oh,
And
mau kemana, Kang?
pH the same, then we can use
Oh
this
iya, lagi
recovered
keluar.
chrome just it is recommended that not to use this recovered chrome alone. 1/3 of the virgin chrome, you can mix this chrome and reuse this. It will be very much helpful, because recovered chrome, if the process are not controlled in well manner, then they have an opportunity to found a little bit excess amount of chromium 6 through the inside that there may be generate heat and any other lack of controlling system. So it is suggested and recommended that the people can use this recovered chrome in the 1/3 of this, or they can make a trial that whatever is suitable for them. It's basically training. It depends on the trial. You can make a trial and adjust your existing process and reuse this chrome.
Benar-benar. 26.
Okay. Yes, thank you very much for the answer, Mr. Feroz. It was very clear.
Okay,
Thank you.
thank you so much, Mr. Firoz. So maybe any question, other question?
Berapa nih?
Okay, I think it's really clear. So maybe the discussion session is enough.